Okay, so the question we left the last video at was, which pair of these forces could produce a resultant of 18? Okay, so hopefully you turn the video off when it finished, or turn this off now and see if you can figure it out before I do the answer. Okay, so the key is what I said a minute ago in the last video. If you add them, you get the maximum force, and if you subtract them, you get the minimum force. So if we add 40 and 20, we get 60 newtons. And if we subtract them, we get 20 newtons. So this pair of forces can only produce a forces in between 20 and 60, and 18 isn't. If you add this pair, you get 30 newtons. If you subtract them, you get 20 newtons. This pair can only produce forces between 20 and 30, 18 isn't. This pair, if you add them, you get 25. If you subtract them, you get 15. 15 falls in between 20 and, 18 falls in between 15 and 25, so it's good. Check the last pair, 45 newtons and 35 newtons. 18 does not fall in here, so the pair that can produce a force of 18 newtons is this one. Now we don't know what angle they're at, we just know that it can do it because it falls between the maximum and the minimum. Alright, one last definition, and that last definition is called the equilibriant force, we'll call it. Equilibriant force. Okay, so to imagine this force, think about a box or something, and imagine you're pulling with a force of, 10 newtons at an angle of 30 degrees, let's say. And someone else is pulling with the force this way, and maybe their force is 20 newtons, and their angle is 60 degrees. Clearly this box is going to move to the right. But what if you didn't want it to move to the right? Well, if you didn't want to move to the right, you would have to apply some force backwards somehow, and we're not exactly sure what angle, but this way, that would have to be equal and opposite to these two. This guy, then, is called the equilibriant force. It's a force that is equal and opposite to the sum of all the other forces acting on the object. So we could add F1 and F2. I could pick up F2 and draw it so that it's head to tail with F1. And I could even do it to scale if I want. And then I could draw in my resultant. This would be F1 plus F2. And I could find it. And then F3 would have to be equal to it, but in the opposite direction. And so that's the definition of equilibriant force. A force that is equal in magnitude, but opposite in direction to the sum of all the other forces acting on the object. So if we wanted to do an easier one, we could have a person pulling with 50 newtons this way, and another person pulling with a force of 80 newtons was this way. So clearly the box is going to be going that way. So if this is east and this is east, the resultant then would be 130 newtons east. So my equilibrium force, FEQ, would have to be 130 newtons west. Okay? So that's equilibriant force. So now if we were in class, I would give you a sheet of paper that looked like this, and really it's only one side. I just was saving paper, so the two columns are the same. And I would ask you to do these ones tonight. Okay, so if you can read these, you might want to try them. Yeah, but it's the wrong side. Oh, shoot. So it's really this side I would give you. Sorry, the back side is with equilibrium, so don't read that. Here, read this side. So I would give you this sheet and ask you to try these 5 questions. Okay? Pick it up a little so you can see the whole thing. So the first one's asking which pair of concurrent forces. The second one's asking about resultant. Alright, so try these, and on the next video I will do the solutions to them, and then we'll do an example with equilibrium, and then we'll move to the force of gravity. Alright, and remember you have some kinematics questions to work on.